This video will function as a review of technical or schematic symbols and will add the concept of signal flow that we just reviewed in the previous video on mixing consoles. To begin with, this is the symbol for a loudspeaker. And a loudspeaker is an inductive device with a coil that creates a magnetic field in the presence of a magnet that moves a cone in and out to convert electrical energy to audio energy or sound. The symbol for an amplifier is simply a triangle, in this case with the input on the left and the output on the right. The symbol for a microphone is the circle with a flat line and then the two wires coming out of the left side in this case. A resistor has two symbols, the either squiggly line or the rectangle, and typically the squiggly line is the United States and the rectangle is Europe, or the old and the modern or new way of describing a resistor. A variable resistor is also called a potentiometer, and it adds a third wire with the resistor having the leads on the top and the bottom, and then the third wire is a wiper that moves from one side, or in this case the top, to the other side or the bottom, therefore varying the amount of resistance between, for example, the top lead and the center lead. As you move it up, the resistance gets closer to zero, and as you move it down to the bottom, the resistance between the top lead and the wiper or center lead is the full value of the resistance. Now, potentiometers come in two different styles. The first one is the round style, which has a shaft in the middle, which usually has a knob, and as you turn it from the left to the right, you can see there's a little circular pad on the left side and a circular pad on the right side. Those are the two outside edges of the resistor, and the material in that circular C-shape changes resistance as you go from one side to the other. The center terminal is connected to the shaft, and then that little slider or wiper wipes from the left side to the right side as you turn the knob from the left to the right. And that's how you vary the resistance. The other way a potentiometer is built is in a linear or slider fashion. And if you look at this one, the left and the center over on the right-hand side, the left and center leads represent the level of the resistance from the left side to the right side. And then the third ring or terminal is the slider. And as you move the knob to the left and the right, it slides along the resistive material, allowing you to vary the resistance as you slide from left to right. The ground symbol can be represented using three different symbols. Typically, the one on the right is what we use in the United States, and the one on the left is what is used in Europe. But sometimes you'll see these designating different kinds of ground, like a general ground, an earth ground, the diagonal line in the middle, or a neutral if you have a bipolar power supply, meaning a power supply that has both positive and negative directions. To look at a simple block diagram, putting some of these components together, we're first going to start with a microphone, and then we're going to flip that over so the wires are on the right-hand side, and we'll add an amplifier, and then we'll add a potentiometer, which is a volume control, and then we'll add an amplifier, and then a speaker. And this is a simple PA system, public address system. And what you notice there is you have to complete the circuit by adding the ground symbols as well. So the microphone is connected to the ground, it passes through the amplifier, then it goes to the volume control, which varies the level from full volume at the top to being grounded at the bottom, which means no volume. Then it passes through the amplifier and finally to the speaker. Now, another way to look at the electronic symbols is you'll have a module or a block, and this consists of an input, some sort of a processing function, and an output. And we've seen these in terms of our recording console, where we have a low-pass filter. So you have the input, the function is low-pass filter, and the output on the right side, or a high-pass filter. And then if you remember, there were those two bell-shaped curves as part of our equalization system. And one was the band pass filter, which allows a certain band to pass through, with the lower left edge being the low frequencies and the right being the high frequencies. And the opposite of a band pass is called a band reject filter or a notch filter. If you were looking at a circuit that would only allow electricity to flow in one direction, your module or block might consist of a rectifier. Now, a rectifier only allows voltage to pass through it in the direction, for all intents and purposes of our class, of the arrow. So this would, if you had a sine wave, it would block the lower half of the sine wave, so only the upper half would pass through this block. Now again, you've got a block, you've got a function, and you've got an output, and sometimes there is another input going into the function which is called a control port. And this is used to vary the value or the operation of the function based on some external input. So in this particular case, we're going to look at a voltage-controlled amplifier, and we're going to connect the input to a side chain, which could be an equalizer or a gain control or some other type of effect, and we're going to run that into the input of the voltage-controlled amplifier, which gives us the ability to control the level of the amplifier function based on the output of that side chain. Another way to look at this is you might take the output of the function, the voltage-controlled amplifier, and use the side chain to control the level of that amplifier on the output side. Some of these functions for both the either input or the output side of this might be a compressor or a limiter that's used to control the level of a signal based on either the input or the output of the amplifier. Now, looking at our side chain again, you might have one of those rectifiers that only allows part of the signal to pass through, and then a low-pass filter, and that may be controlled by two different inputs that vary the amount of the low-pass filter and the frequency of the low-pass filter, and then you're going to amplify the output and then send it to the output of the entire block. So all of those functions, the rectifier, the low-pass filter, and the amplifier, are the function of this particular system. The next component we'll look at is a coil. A coil is an inductor, and if you remember, the inductor acts like a resistor to an AC circuit, which AC is audio. DC is just a flat level. AC would be our varying level of audio. When you put two coils together with a magnetic or inductive core, you end up with a transformer. And if you remember, changing the number of coils on the left side versus the right side will allow you to change the voltage from one voltage to another. That's one purpose of the transformer. Or simply having the same number of coils on both sides, as can be seen in this diagram, is used to simply isolate two circuits, because the AC signal will pass through the magnetic material from the left coil to the right coil, but there's no electrical connection between the two, therefore acting like an isolation transformer in this case. The other component we looked at was a capacitor, and there are two types of capacitors. One is a non-polarized and the other is a polarized capacitor. The polarized capacitor and the non-polarized can have either picture as seen here, with the exception that a polarized capacitor will have one of the plates with a plus sign either on the top diagram or the bottom, and if the capacitor on the bottom were non-polarized, it would have two clear or two black rectangles instead of one black and one clear. AC voltage, we can have a plus 12 volts, which has a nominal level of 6 volts in the middle there. Or we can have a negative 12 volts, or we can have a plus minus 12 volts, which has a 24 volt swing from top to bottom. DC voltage can either be a positive 12 volts or a negative 12 volts, or plus and minus 12 volts, again, which has a 24 volt differential between the plus 12 and the minus 12. The next components that we'll look at will be peripherals. Peripherals are usually components that are added to a circuit to give you more of an insight as to what the circuit is doing. For example, a meter is indicated by an arrow inside the circle, and you can think of that as the arrow swiveling around the center point as though it were a hand on a clock, for example, going from the left to the right, left being a lower signal, right being a higher signal, for example. And if it's a VU meter, you're going to put VU in the center of the circle, VU standing for volume units. If it's a voltmeter, you would have just a V for volts. A current meter will have an A symbol for amps or amperes. And a tone generator, for example, your 1 kilohertz, or even maybe a noise generator, will have some sort of a symbol inside of the circle to indicate what it is. And now we're going to put all of these little diagrams together, and we're going to look at the mixer that we looked at in the previous video. So we're going to start with the line input and the microphone input, and the microphone is going to have a balancing transformer or a matching transformer, and then there's an amplifier over on the right-hand side of the diagram. So first we connect pin 2, the plus pin of the microphone input, to the top of the transformer, and the pin 3 or the negative input to the other half of the transformer. And the combination of the ground on pin 1, the positive on pin 2, and the negative on pin 3 completes our initial circuit for the microphone input. We're going to take the output coil of the transformer and connect one side of it to ground, and then connect the other side of it to the preamplifier stage, which has its negative input also connected to ground. So to complete that circuit, we add the wire at the bottom, which just connects the two grounds together. And now we're going to add a switch so we can select between the microphone input and the line input to our preamplifier. At this point, we're going to add a couple more components, a resistor and a potentiometer, that will act as the gain control for our preamp stage. Now notice we're feeding some of the output of the amplifier back to the input, which is going to allow us to increase the gain of the signal, either the microphone or the line, depending on the position of the switch. Gain, again, as we mentioned in the last video, is an active level adjustment process. So you want to turn the gain up as little as possible to get that nominal signal level, because the higher the gain, the more noise, and the more noise reduces your signal to noise ratio. So these two components are resistors, and the ratio between these two resistors is equal to the gain. The next thing we're going to look at is we're going to add some more components, some more resistors that are going to create that 20 decibel pad. And if you notice, the top resistor is hooked up to pin 2, the plus pin. The bottom resistor is hooked up to pin 3, the minus pin of the XLR. And then there's a resistor that mixes the two of those together. The ratio between these three resistors create a passive balanced voltage divider, or pad, which is our 20 decibel pad. And again, because components add noise, we're only going to use the 20 dB pad if we cannot turn the gain down enough on the microphone input to get the nominal signal level that we're looking for. So when we're connected to the line input, the orange line represents the signal flow through the preamp and to the output of the preamp. When we switch the switch to the microphone input, we now follow the orange line from the positive lead through the transformer and then to the output of the amplifier. But because the microphone is balanced, we also have the blue line that we can follow through, which gives us the other half of the circuit. Now, adding the pad to the circuit, we're going to add these three components into our circuit. So we have the positive lead is now going to follow this orange path, meaning that part of the signal is going to be diverted through the vertical resistor, and the pad again is only used when turning the gain down is not enough. And now we see the negative signal follows the blue path. So we've basically added those three resistors, the orange and the blue, and then the orange-blue combination to give us our signal flow. The next thing we're going to look at is adding the phase switch. And if you look at this, when the phase switch is in the 1 position, the top position, we have the signal flow of the positive following the orange line and the negative following the blue line. By flipping the phase switch to the other direction, we are basically reversing the signal flow of the positive and the negative lines of the microphone input. And therefore, we will flip the phase or flip the sine wave 180 degrees using the phase switch. The next component that we look at is phantom power. When the phantom power switch is in the off position, then we do not introduce 48 volts into the pin 2 and the pin 3 lines of the XLR cable. But when we flip the phantom switch to the on position, those two resistors act like a current barrier to keep the audio signal from flowing back to the 48 volt supply. But if you notice, those two resistors are the same voltage, and in reference to the ground, they are added to both pin 2 and pin 3, but they will not pass through the transformer. And that's what allows us to send 48 volts to whatever is plugged into that microphone input to power a preamplifier, such as a condenser microphone or a direct inject box. Again, the DC voltage does not travel through the transformer, therefore it only affects what's plugged into the microphone input. The next step we look at is on the output of the preamplifier, we go into our equalization circuit. And remember, whenever possible, we want to bypass the equalizer so we don't add any noise or inductance or phase shift to our signal. So we leave the switch in the bypass position when we do not need the equalization. When we do need the equalization, we flip the switch to the EQ position, and therefore we now have the signal flowing through the equalizer, and we can adjust the frequency content of the signal. After the equalization, we go through the fader, which again is a potentiometer or variable resistor. And then we're going to break the signal between the preamp and the equalizer, and we're going to add an effect send and an effect return that are normally connected together so the circuit continues without anything plugged in there. The effect send and return is typically represented by a tip ring sleeve 1/4 inch connector. And the tip ring sleeve connector looks like the 3 parts on the left. When there's nothing plugged into the circuit, the tip is connected to the ring, to the switch at the top. The ring is at the bottom, and then the sleeve is the little circle that the 1/4 inch connector on the right plugs into. That's also the neutral or the ground connection. There is a switch contact on the tip that allows the tip to be connected to the center part of the switch, and that becomes our send and return for the circuit. So with nothing plugged into the circuit, you can see that the signal starts at the send, goes through the tip, returns through the switch back to the return side of our mixer circuit. When a plug is plugged into the connector, the switch opens, and now the send is connected to the tip of the 1/4 inch, which then goes out to the peripheral equipment plugged into the TSR or TRS insert, and it comes back through the ring and then goes into the remainder of our mixing circuit. So this is what happens in the lower right-hand corner with that insert connector. You could either have it not connected and the signal flows through the switch, that's part of that connector from the send to the return, or when you plug a connector into it, the signal now is sent through the tip to the peripheral or outboard equipment and then back in through the return to our mixing console, and then on to the equalization and so on. Over on the right-hand side, we're looking at our foldback, which is going to be pre-fader. And if you remember, foldback is the monitor send for the musicians. So the foldback output is now our orange connection, and that, or orangish red, and that again gets sent to the performers, and it's pre-fader. So what we do with the fader doesn't affect what they hear in their headphones, in-ear monitors, or on-stage speakers, because it's really obnoxious if our level changes affect what they hear. The more we turn it down, the more they play louder, for example. After the fader, we have post-fader effects, which are the AF, after fader, and the PF, pre-fader sends. And these are used, the after fader are used for effects like reverb and so on. And again, this is a review from our last video. So we've got our blue signal, which is the after fader, and our red signal, which is the pre-fader outputs. And then the other place that we send the output of our fader is to our pan or panorama control, which lets us adjust this particular channel to the left and right mix buses for a stereo output. And that's indicated by the pan outputs left and right. As we move the pan control to the left, we get more signal on the left side, or we move it to the right, we get more signal on the right side. And remember, when the pan knob is set in the center, we are at -4 dB on both the left and the right output by design. So the signal coming out of the pan control into our left and right buses doesn't sound 3 dB hotter when we're in the center. It's designed to be -4 when the control is in the center. So these represent the different outputs of our mixer. And then the outputs left, right, after fader, and pre-fader are now represented by the single box on the left. And remember, this is a block diagram or a function at this point. And we can see our pan output. So our channel outputs, all 4 of them are still represented here. And that's for one channel of our mixer. In this particular case, our mixer has 8 different input channels or 8 different channel strips. So all of the left outputs are connected together. All of the right outputs are connected together. All of the pre-fader aux sends are connected together. And all of the after fader effect sends are connected together. And when we look at the whole diagram together, those are considered the buses. We have the left, the right, the pre-fader, and the after fader. And the left output is connected to another potentiometer, which is the master level for the left channel. Then there is the amplifier, which is the buffer amplifier for the left output. The same thing for the right output with its own fader, and the dotted line between those two indicates that both of those faders move together. There aren't, in this particular case, separate knobs. They are 2 different potentiometers or faders built into one unit. You then have the pre-fader aux send, and then you have the post-fader aux send. And again, those are separate volume controls or faders for each of those, and they have their own buffer amplifiers. There is also an aux return for the left channel and an aux return for the right channel, and these allow you to have those effect units, the reverb units or the external EQ, come back directly to the left and the right master outputs of your console. And so basically you're summing all of the left outputs and all of the right outputs together, and then you can add VU meters or volume unit meters to each of those. So you can have the master output, you can control the level or view the level of each of those. And then, of course, we talked earlier about having the local headphones for the mix engineer with their own volume controls are also connected to the master left and right output. And then the only other thing we're going to talk about is a real quick view of how a patch panel works. Now, in a patch panel, what you would do is hook all of your gear up to your mixers, your equalizers, etc., to a patch panel, so you're not having to crawl behind all of your equipment and move wires around when you want to add an external equalizer or something else to your circuit. So patch panels have jacks on the front and the rear panel, and in this particular case, these are what are called all parallel non-switching. And when you plug a cable in to the left side to the rear panel, if you notice, the signal is going from the tip of the top connector to the tip of the bottom connector, and it's also hooked up to the tip on the right-hand side of each of the 2 connectors. But all 4 of those connectors are connected together at any given time. So an input signal coming in on the left-hand side is actually going to all 3 of the other jacks in the panel. That is basically called a splitter. So you have 1 input signal and 3 output signals. The other way that you would look at a patch panel is a 2-way throughput non-switching. And in this case, you don't connect all 4 of the jacks together. you only connect the top two and the bottom two individually. So as you plug a jack into the rear panel and then the front panel, if you notice, the output of your effect unit or your equalizer or your dynamic processor, the output is the green arrow on the lower left side, and that plugs into the bottom jack, and then the connector connects it to the front panel as an output. That would go to your mixer. And then the front panel on the top right is the signal coming from the mixer that passes through the patch panel to the rear side and becomes the input of your effect unit. So in essence, what you have is the signal is sent from the upper right through the jack panel to the effect processor. Through the effect processor, it is a return signal coming back through the patch panel. And again, you would have equipment permanently connected to the patch panel, and this allows you to just change patch cords to reconfigure the way your studio is laid out. And again, this video is a theoretical video since we don't have the opportunity to actually see this equipment in operation. So this is a review of technical or schematic symbols and the signal flow that we saw in the mixer video previous to this one.